We'll solve today question number 41 to 50 of JAM Mathematical Statistics 2020 question paper. So let's start with 41 question. So this is a limit of root under n square plus 1 plus n whole square upon n6 plus 1 cube root. So when we put n is equal to n tends to infinity, it will be 0, infinity upon infinity. So it is infinity upon infinity. So what can we do? So we try to let's take common n from the numerator. Limit n tends to infinity. So from the bracket, try to take out n. So from the square root, you take comma n square, so that we'll get n outside the square root. So it will be 1 plus 1 by n square and plus 1 and whole square. So from inside bracket, I have taken n common. In the denominator, it is n raised to the power 6 plus 1 whole power 1 by 3. So what I can do, I can take common n raised to the power 6 from the bracket, and since it is 1 by 3 power, so n square will come out. So in numerator, you separate the square, it will be root under 1 plus 1 by n square plus 1. So separate the bracket, okay, a square on each term, so n square into this. In denominator, we take n raised to the power 6 common from the bracket. So after the bracket, it will be n raised to the power 6 into 1 by 3. So 6 into 1 by 3, n, so n square you will get 1 plus 1 by n raised to the power 6 whole power 1 by 3. So from the bracket, I choose n raised to the power 6. So n square cancel. So we have to use limit n tends to infinity. So now, since n tends to infinity, so 1 upon n square tends to 0, and 1 upon n6 will also tend to 0. So we are left with 1 plus 1 whole square, here 1 raised to the power 1 by 3. So it's a 2 square 4. So answer is 4 for the first one. So answer of 41 is okay. Let's come to 42. So in 42, they are asking for maximum value of the function this. So to find the maximum or minimum value, I will use maximum minimum concept. So we have fx x square upon x raised to the power 4 plus 4. Since we can see this is a positive function, or we can say non-negative function. This cannot take negative value. So 0 is a minimum value of this function when we put x as 0. But I don't need minimum, I need maximum value. So for that, let's find f dash x. F dash x, apply quotient rule. So denominator is b square, derivative of numerator is a 2x, and denominator as it is, minus derivative of denominator, it's a 4x cube, numerator as it is x square. So after simplification, it's a 2x raised to the power 5 plus 4 to the 8x minus 4x raised to the power 5 upon x raised to the power 4 plus 4 whole square. And to get the maximum or minimum value, what we do, we'll put f dash x equal to 0. So put f dash x equal to 0. So, but let's simplify. The numerator, it's some 8x minus 2x5 upon x4 plus 4 whole power 2, that is 0. So from here we get either, so 8x minus 2x5 is 0. So from here what will we get? So we'll get, I will write here, so we'll get x 0, or we'll take x common, or 2x common in fact. So we'll get 4 minus x, 4 minus x4. So after simplifying this equation, we'll get two things, either x is 0 or x4 is equal to 4. So since we know that when we put x 0, it will give 0. So at x 0 is 0, we are going to get minimum value. But we are interested in maximum value. So the other condition is x raised to the power 4 equal to 4 means x square is 2. So at x square 2 we'll get maximum value. So put x square equal to 2. So 2 upon 2 square 4 plus 4. So 2 upon 8 is 1 by 2. means 0.25. So 0.25 is the answer for second question, means 42 number question. So let's come to the 43. 43 is the value of the integral ex upon root x dx dy. X has limit y square to 1, y has limit 0 to 1. So since integrating this function with respect to x is difficult, so for simplicity, I would like to change the order. So it will be e raised to power x upon root x. Just change the order. So x has limit y square to 1. So let's make the graph. X has limit y square, means x is equal to y square. So x is equal to y square is this function. 2x is equal to 1. So x is equal to 1 is this. So 1 is x is equal to y square and 1 is x is equal to 1. So square to x is equal to 1. And this straight moves, so y is between 0 and 1. This goes between 0 and 1. Now I want to change the order, so I will take now because first we need the limit of y. So y start with bottom part is x-axis, that is y is 0 to y will be here root x. This is y square, so means y is root x, and x will have limit 0 to 1. Will have limit 0 to 1. Yeah. So now let's integrate with respect to y. So this function has no y, so it will be treated as constant with respect to y. So the integral we get is 0 to 1. E raised to power x upon root x will be treated as constant. So integration of 1 with respect to y is y, and limit is 0 to root x. So root x minus 0, that is root x into dx. X cancel. Now we have e raised to power x with respect to x, and limit is 0 to 1. So let's integrate it. E raised to power x, limit is 0 to 1. So e raised to power 1 minus e raised to power 0 means e minus 1. So e minus 1 is the answer. So e minus 1. E is what? So if you don't know, in exam calculator is given on the screen. You just put e is equal to, it will give you 2.718 minus 1. So 1.718 answer. So but they want answer till up to 2 decimal. So you can write a answer as 1.71 or 1.72. Both will be correct answer. So 1.71 or 1.72, you can write any one of them. Up to 2 decimals only you have to write. So that will be treated as constant. Correct answer. Let's come to the next question. 44. So 44 is the question to find rank. So rank is the, just try to make this upper triangular matrix. Matlab, make all the elements below diagonal 0. Then the number of non-zero row or number of linearly independent row will be the rank. So for that, what will I do? So apply operations. So we use elementary operation. So subtract second row, change R2 minus R1. Okay. Change R3 minus 2R1. Change R4 also, R4 minus 2R. Because first row it will be as it is. So I want to make the all elements below diagonal 0. So second row minus first row, so 0, 1, 2, 1. Third row minus 2 times first row. So 0, 3, 4, 2. Fourth row minus 2 times first row. So 0, 4, 6, 3. Now, with respect to this one, I can make this 3 and 4 0. So apply the operation. So first row as it is 1, 1, 1, 1. In second row, keep it as it is 0, 1, 2, 1. Now change the third row. Third row minus 3 times second row. So change the third row now. Third row minus 3 times second row. Change fourth row also. Fourth row minus 4 times second row. That is 0, 0, 4 minus 3 to just 6, minus 2, 2 minus 3, so minus 1. Now 4 minus fourth row minus 4 times second row, so 0, and so minus 2, 6 minus 4 to the 8, minus 2, 3 minus 4, it's a 1 minute, so it's 0, and it is minus 2 because 4 minus 4 0, 6 minus 8 minus 2, and 3 minus 4 is minus 1. So now you can see, okay, third and fourth row are equal. So let's change fourth row. Fourth row as fourth row minus third row, because we want to make it a upper triangular matrix. Means all the elements below diagonal must be 0. So now resulting matrix I have 1 1 1 1 0 1 2 1 and 0 0 minus 2 minus 1 0 0 0 0. So now it is a upper triangular matrix, and you can count the pivot elements. So this row is 0, so it will not contribute in rank. So rank is 3 only. So number of non-zero row, number of linearly independent row, that is 3. So rank of this matrix answer is 3. So let's come to the next question, 45. So 45 is what? XY have the joint PDF as this. So they want us to find conditional expectation. E of x given y is equal to 1. So what is the formula of conditional expectation? E of x given y is integral x f of x given y means x given y dx, whatever limit of x is. So for that you need f of y, so x given y unit, and that is f of x comma y upon fy of y. So for that you need fy. So what is f of y? So it will be integral of joint PDF with respect to x, and limit of x here will be 0 to y. Okay, and so now let's integrate 0 to y, 3 by 4 y minus x dx. So I think so the other tab. So fy of y I will get is 3 by 4 as it is, integral of y with respect to y, because y will be treated as constant. Integration of x square with respect to x square by 2, limit is 0 to y. So 3 by 4 limit of x is y, so y square minus y square by 2. So finally 3 by 4 into y square by 2. So 3y square upon 8. This is condition. This is actually marginal PDF of y. So let's find f of x given y is equal to 1 actually. So first x given y. First x given y. Okay. So according to formula, this. So this was 3 by 4 y minus x upon 3y square by 8, and the limit of x is now 0 to y. Okay. So, but we wanted to find f of x given y is equal to 1. So f of x given y is equal to 1. So put y is equal to 1. So 3 by 4 1 minus x upon 3 by 8, and limit of x will be 0 to 1. Okay, because y was given here. So 4 to the 8, 3 3 cancel. So finally we get it as 2 times 1 minus x, and where x lies between and 1. So this is what? This is a conditional PDF of x given y is equal to 1, but we wanted to find conditional expectation. So conditional expectation is what? So I have to go to next. So 2 into 1 minus x I have. So let me do here. So I should remove the definition. Okay. So it's a x 2 times 1 minus x dx limit 0 to 1. So 2 take outside 0 to 1 x minus x square dx. So this 2 outside and x has integration x square by 2. X square has x cube by 3. Limit would be 0 to 1. So 2 times it's a 1 by 2 minus 1 by 3. So that is 2 into 1 by 6. So it's a 1 by 3. So answer is 0.333. This. So we have to see what they want. So they were asking round up to 2 decimal place. So you can write 0.33. That's correct. 0.34 will also be correct. 0.33 you can write here. Yeah, thank you. So I'll start next also. So next question is 46. Next is 46. So 46 question is what? Let x be the random variable having Poisson 4 distribution. Okay, lambda is 4. E be the event such that probability of E given x is equal to I is 1 minus 2 raised to the power minus I. I from 0, 1 to up to infinity. Probability of E is. So we can use total probability concept. So we can write here probability of E can be written as probability of x is equal to I into probability of given x is equal to I, and I can take values from 1 to infinity summation. So this is the formula. So this is formula for total probability concept, you can say. So it's a summation I from 1 to infinity. Probability x is equal to I is what? So x was a random variable, Poisson 4. So e raised to the power minus 4. Sorry, e raised to the power 4. So sorry, e raised to the power minus lambda. So PDF for Poisson is e raised to the power minus lambda. Lambda raised to the power I upon I. So I'm using I. Is from 0, 1 to 1 up to infinity. So this is probability at x is equal to I. So I will use e raised to the power minus 4 by 4 raised to the power I upon I factorial. And probability of E given x is equal to I is 1 minus 2 raised to the power minus I. And I varies from 1 to infinity. Now we need to solve this. So summation I from 1 to infinity e raised to the power minus 4 can be taken outside because it is free of I. So summation में इसका कोई काम नहीं है. So e raised to the power minus 4 can be taken out. So now we are left with 4 raised to the power I upon I factorial. So 2 raised to the power minus I can be written as 1 upon 2 raised to the power I, and we can take LCM. So after taking LCM, it is 2 raised to the power I, 2 raised to the power I minus 1. So if we cancel it, so 4 raised to the power I upon 2 raised to the power I. So क्या होगा? 4 raised to the power I को हम लिख सकते हैं 4 is 2 square is 2 raised to the power 2I. 4 raised to the power I can be written as 2 raised to the power 2I. So 2 raised to the power 2I upon 2 raised to the power I. So ये बचेगा समय. अच्छा. So we have e raised to the power minus 4 summation I from 0 to taken 1 to sorry. So by mistake I have taken 1 to infinity, so 0 to infinity. Okay. So I from 0 to infinity. Now it is left with us 2 raised to the power I upon I factorial into 2 raised to the power I minus 1. Yes, so we have to open this bracket. Okay. So e raised to the power minus 4 and the summation I from 0 to infinity. Let's open the bracket. I factorial. Okay. So 2 raised to the power into 2 raised to the power. Again, it's a 4 raised to the power I. 2 to the 4 raised to the power I. Or 2 raised to the power 2I. Write the same thing. Upon I factorial minus. Then 2 raised to the power I into 1. 2 raised to the power I factorial. Summation is over both. So e raised to the power minus 4 is outside. So 4 raised to the power I upon I factorial. I from 0 to infinity. You know the expansion of exponential function ex. that is e raised to the power 4 actually, minus 2 raised to the power I upon I factorial, and summation from 0 to infinity. So this is exponential of e square. So finally, e raised to the power minus 4 will be shifted into bracket. So e raised to the power minus 4 into e raised to the power 4, that is 1, minus e raised to the power minus 4 into e raised to the power 2, so e raised to the power minus 2. Now in exam, calculator is allowed. Okay, I mean calculator will be on your screen, so you can use that. So if you want me to calculate, I can calculate for you. So it will give you the value. So I'm not able to open the other tab. So you put it on calculator, you will get value approximately, I think 1 upon e is 2.718. So 1 upon e square, so it will be 2 to the 4, something 5 point something, 1 upon 0.2, 1 minus 0. Yeah, 0.7 something you will get. So you calculate on calculator. Okay, let's go to the next question. So next question, 46 we have done. So 46 you calculate on calculator, 1 minus e raised to the power minus 2 is the answer. Now 47. The 47 question is, let x1, x2, x3 be the independent random variables such that x1 is normal 4710, x2 is normal 5515, and x3 is normal 6014. Then x1 plus x2 getting equal to 2x3 equals. Okay, so then you probability. So we can do one thing, x1 plus x2 minus 2x3. This will get equal to 0. So I will try to convert into the standard normal form. So just find the expectation of x1 plus x2 minus 2x3. It will be, you can separate the expectation x1 plus expectation x2 minus 2 times expectation x3. So it is 10, sorry, expectation, not variance. So first is mean variance, 57 plus 15 minus 2 into 60. So that will we get 120 minus 10. Okay. So 62. Sorry, it is 50. Okay. So 0.2 minus, that will get minus e. And what is variance of this? So let me write it here only. So I want to convert this. Let's name this t. Suppose I name this t. x1 plus x2 minus 2x3. I name it t. So expression of t I got is minus 18, and variance of t, if you calculate variance x1, that is 10, variance x2, that is 15, and minus. So in variance, what happens? Minus 2 square will come out. So it's a 4 plus 4 times variance of x3 is 14. So it will be 10 plus 15 plus 56. So 25 plus 56, that is going to be, okay. So t minus, I named it t. So t is more than equal to 0 until now. So t minus 18 upon so t minus 18 upon standard deviation I need. So root of variance more than equal to 0 minus 18. Okay. So t minus mean of t upon this. So upon root 81 is 9. So it's a minus 18. So I will get so normal z now t minus mean of t upon standard deviation of t. Z is more than equal to 2 upon 18 upon 9 plus 18 upon 9. So plus 18 minus of minus 18. So 18 upon 9 is 2. So we can write 1 minus probability z is less than 2. So since it is continuous random variable, so 1 minus 2. Again, phi 2 will be given in your question. In the first page, the introduction page, it will be given to you. In second page, phi 2. If you want, I can show you. So phi 2 must be given to you. So phi 2 in the initial page you will get. So this is the question for 2020. So first page is instruction, and then after instruction, second page is a special instruction or useful data. So see at the bottom. So we have given phi 0.5, phi 1, phi 1.5, phi 2. Phi 2 is 0.9772. 0.9772. Okay. So phi 2 is 0.9772. So I will put 1 minus 0.9772. So subtract it, you will get 8, I think 9.72. Yeah, so it's a 0.0228. So how many decimal it want? The question asks you to give round up to 2 decimal place. Okay, so 2 decimal place it wants. So you have to tell 0.02. You can write 0.02. Okay, it's 0.02. Thank you. So next we see. So next I have 48. So let U is F distribution with degree of freedom 5.8. V is F8.5. So first of all, what is the relation between them? So 5.8. So you know already U will be 1 upon V, or you can say V will be 1 upon U. So since U has distribution F5.8 and V has F8.5, so U is equal to 1 upon V, or V is equal to 1 upon U. So probability of U more than this is given. So I will proceed with this only. So then the value of C such that probability of V more than C equal to 0.95. So we'll start with this. So U you replace 1 by V, that is more than 3.69, and this is equal to 0.05. So from here what will you get? Do reciprocal inside bracket. So V will be less than, after the reciprocal it will be less than 3.69, and that is 0.05. So inside bracket I did. So but we need V more than C. So I can do 1 minus. So probability V more than 1 by 3.69 is equal to 1 minus 0.05. That is 0.95, right? So V more than 1 upon 3.69 is 0.95. And here it gives you probability V more than C is 0.95. So what is C? So C you get 1 upon 3.69. So using calculator you calculate this, what it gives you. C is 1 upon 3.69. So put on calculator 1 upon 3.69, you will get the value of C, and that you have to put there. So 1 upon 3.69 is value of C. So next question is 49. 49. Let the sample mean based on a random sample from exponential lambda distribution be 3.7. So suppose like x1, x2, xn, that is random sample. So x bar, observed value of x bar is given to us. It is 3.7. Then the maximum likelihood estimate of 1 minus e raised to power minus lambda. So distribution is exponential lambda. So PDF, you know, this is lambda e to power minus lambda x. Okay, do you know what is the maximum likelihood estimator of lambda? So you prove it, however, you know. So let me tell you, the MLE of lambda in the exponential lambda is 1 upon x bar. Okay. So when you maximize the likelihood function, you will get lambda is 1 upon x bar. So 1 upon x bar is the MLE of lambda. So I need MLE of 1 minus e. I need MLE of 1 minus e raised to the power minus lambda. That would be 1 minus e raised to the power minus 1 upon x bar. So 1 minus e raised to the power minus 1 upon x bar. So 1 minus e raised to the power minus 1 upon x bar was given to us 3.7. Again, the use of calculator. So you use calculator. So first find e raised to the power minus 1 upon 3.7, then subtract from 1. So you will get the value. So using calculator, you calculate it. Okay, so next question, 49, then come to 50. So till 50 we'll do today. So let x be the single observation drawn from uniform 0 theta, where theta will be 1 or 2. To test h0, theta is 1 against h1, theta is 2. Consider test procedure rejects h0 if and only if x is more than 0.75. The probability of type 1 and type 2 error are alpha and beta. So find the alpha plus beta. So I need alpha plus beta. So let's see. Alpha is rejecting h0 when h0 is true. And type 2 error is rejecting h1 given or when h1 is true. So when can we reject h0? So we can reject h0 if x is more than 0.7. Just given to us. Given h0 is true. So when h0 is true, theta is 1. Plus probability reject h1. So h0 will be rejected if x is more than 0.75. So reject h1 means accept h. Yeah. So rejecting h1 here. Probability of rejecting h1. So h1 will be rejected if x is less than 0.75, because we are rejecting h0 when this. So you'll reject h1 opposite condition. So x is less than 0.75 and given h1 is true. So h1 is true when theta is true. Now we have given the PDF. PDF is distribution uniform. So what is PDF of this? 1 upon theta when x is less than theta more than 0. So this is fx. So probability x more than 0.75. So the integration more than 0.75. 0.75 to theta is 1 to 1. And PDF is 1 by theta. Theta is 1 dx plus x is less than 0.55. So from where 0 to 0.75. 1 upon theta is PDF. So theta is given to 2. I will put 1 by 2. So 1 upon theta is a PDF. That's why dx. So integration of 1 is x. So 1 minus 0.75 will be 0.25. And 1 upon 2 and the integration x. So 0.75 minus 1. So I mean minus 0. So 0.75 upon 2. So 0.25 plus 0.75 upon 2 will be 0.375. So you can add it. 250 plus 357. So 375. So 5, 2, 6. 0.625 is the answer for this question. So check the calculation if I have done something wrong. So yeah, thank you everyone.